Hey guys, welcome back. This is the problem which is from December 2023 SFM paper, uh, portfolio management problem. This is mainly focusing on the variance part only. Variance and portfolio beta only will be covering in this. It's a that kind of problem, but it's covering the both Sharpe and Markowitz portfolio variance. So we are going to work out both the things now. And what are all the informations we have, we need to what are all the formulas we need to know, and what are all the ideas behind it is we first need to know the beta. Beta is nothing but it's how sensitive the stock against the market. That's the meaning of beta. How sensitively the stock is moving against the beta is what the beta is telling. Variance is nothing but when we club all the kind of securities, all the different securities into the portfolio, how the stock is, how the variance of stock, how the risk of the portfolio is reduced. That's what we are seeing in the Markowitz portfolio variance. And also Sharpe is individually the stocks risk will be high, but when it comes to the portfolio, we club into the portfolio, the portfolio risk will be reduced. That's our ultimate goal. That's the sole motive of portfolio chapter also, to reduce the risk only. We are creating the portfolio, and how we can better manage, and how we can nil down the risk to zero is the main area. Okay. Formula for Markowitz is weight of all the securities, weight of A into weight of A into standard deviation of A, weight of B into sigma B, weight of C into sigma B, the whole square. Everything will be whole square, and it will be look like the A plus B plus C plus the A plus C, B plus C the whole square formula. In that way, this formula is actually framed. And when it comes to the Sharpe index model, the total variance, no, the portfolio variance is the systematic variance plus unsystematic variance. Okay, the systematic variance formula is it's beta square into sigma market square. Okay, now, okay, let's quickly solve this problem. What they have given, see, they have given the portfolio weight and beta. We can calculate the portfolio beta. Multiply this, we can get the 1 minute. Let me take a calculator. 0.3 into 0.4, which is 0.12. 0.3 into 1.2, which is 0.36. 0.4 into 0.5, which is 0.2. Total this 0.12 plus 0.36 plus 0.2, which is 0.68 is the portfolio beta. So we have calculated the portfolio beta. Portfolio beta is very simple. Next comes the let's take up this one, portfolio variance using the Markowitz. Okay, there is a structure to solve this portfolio variance. There are, when it comes to two stocks, it would be very easy. When it comes to three stocks, we have to, if we follow this table, means it would be easy to calculate, and without mistakes we can find out the portfolio variance using under Markowitz. Okay, BG, BZ, DN. Right. Weight of, okay, let it be, let it make it A, B, C. Okay. Or GZN. GZN. Okay. Now, weight of G into variance variance of G. Weight of G into weight of Z into covariance of Zx. So Z to G. Weight of G into weight of N into covariance Ng. Weight of G into weight of Z into covariance Gz. Weight of Z into weight of Z into covariance Z, variance Z, because both Z, no. Weight of N into weight of Z into covariance Nz. Weight of G into weight of N into covariance Gn. Weight of Z into weight of N into covariance Zn. Weight of N into weight of N into variance N. Right. Okay. What's the weight? Weight is 0.30. Okay. 0.30 into variance is 0.015. Right. 0.3 Z 0.3 into covariance Zn Zg, which is 0.030. 0.3 into 0.4 into covariance Ng. Weight of G, which is Zn. If this one calculated, na, this will be finished. If this one calculated, na, this will be finished. If this one calculated, na, this will be finished. This is not required. This is not required. This is not required. Okay, we will calculate these three only, and we'll put the formulas as it is here. Okay, then comes to Z to Z. Z is how much? 0.3 into 0.3 into variance Z, which is 0.035. Then comes Wn, which is 0.4 into 0.4 into variance N, which is 0.020. Okay. Yes, this one is the weight of N is 0.4 into 0.3 into covariance Nz, which is 0.050. Okay, these three alone is not required, because we'll going to put the same values here and here, here and here. So okay, now 0.3 into 0.3 into 0.015, which is 0.3 into 0.3 into 0.030, which is 0.027. 0.3 into 0.4 into 0.020, which is 0.0024. 0.4 into 0.3 into 0.050, which is 0.06. 0.4 into 0.4 into 0.0032. Okay, 0.006, 0.0024, 3 into 0.3 into 0.035, which is 0.00315, 0.0027. Total it, how much will be getting? Plus 0.027 plus 0.024 027 plus 0.024 plus 0. Yes, we got the answer, which is portfolio variance as per Markowitz theory is 0.0299. So we got the values. Now we can go to the next part. Okay, we have to, let's copy. Okay, now we'll calculate the residence variance using each of the three shares. Residual variance. We can calculate the residual variance only by calculating the total variance, because total variance is equal to standard variance into unsystematic variance. Systematic variance into unsystematic variance. Systematic variance is beta square into sigma market square. We have to calculate this first. Okay. Yes, sir. Yeah. Beta square into sigma market square. What is beta square? 0.40 into power square 1.2 square 0.5 square into sigma market square, which is 0.14 square 0.14 square 0.14 whole square. How much will we get? Okay, 0.4 0.14 0.4 0.1796 0.4 1.2 0.4596 0.5, which is 0.2696. So we got the values. Systematic variance we got. Using this we have to calculate the unsystematic risk, which is the residual variance, total variance minus systematic variance, systematic risk, which is okay. Security 1 2 3 sorry, ABC, which I will keep 0.015 0.035 0.020 minus systematic, which is 0.1796 1.4596. Sorry, I've added everything, so it gave a wrong answer, right? 0.4 into square into just 0.003136 1.2 into just 0.028224 4 into 0.0049 0.003136. We should not add, we have to multiply. By mistake we might doing this at cases. We have to be cautious in this. Okay, now we'll get the answer. we got the unsystematic risk values now. Now we have to be using this, we have to calculate the portfolio variance using Sharpe method. Now total portfolio variance is to systematic variance plus unsystematic variance. Same formula, but we are here going to use the portfolio beta, okay, into sigma market square plus weight into sigma e term, right? So what's the weight? We have to square it. 0.3, 0.3, 0.4. Sigma e term, which is we have already found. The thing is, this is already in square terms. 0.011864, 0.006776, 0.0151. Total this into 0.011864, which is 0.0010677, 03 into 0.6776, which is 0.0006098, 0.4 square into 0.0151, which is 0.002416. So we have got the values. Let's total it up. 0.106, 0.01067 plus 0.06098 plus 0.0246, which is okay 0.004095. So we got it. Now portfolio beta is how much? Portfolio beta is 0.68 square into sigma market square, which is 0.14 square plus 0.0040935, which is 0.013156 is the portfolio variance using Sharpe method. That's it. Thank you.